I will be talking about challenges and solutions in harmonization of imaging studies, and more specific in the CENTER-TBI study. The outline of the presentation will be that I will give a slight overview of how we are dealing with the imaging data in CENTER-TBI, the challenges that we face, and afterwards I will show you in more depth which solutions we came up with in CENTER-TBI. So the data flow in CENTER-TBI is as follows. We see on top the centers that are contributing to the CENTER-TBI imaging data repository. These centers are uploading CT and a sub-cohort are also uploading MRI data. These data are uploaded to the Icometrics repository. Icometrics is responsible for the storage, for the quality control, for the central reading, and for the quantification of these imaging data. Afterwards, when these data is cleared and curated, the data will be accessible via the INCF Neurobot system. And also we are synchronized with the clinical data database. It's called Question over here. And afterwards, the researchers will be able to download the imaging data via the INCF data repository. How does the MR centers look like? Like we have in contrary to the TRACK-TBI, we have actually more a mix of academic and clinical sites. We have asked them to scan with a fixed protocol. Only 3 Tesla machines were allowed in the study, and a subset from the centers are doing ultra-early imaging, means that within 72 hours after injury. Since this presentation is entitled Challenges in Harmonization, I put here the issues that we already faced with selecting different centers. We have to deal with different vendors. The main vendors are participating. It means GE, Siemens, and Philips. We have to face that not all centers are using the same head coils. We have to face that not all centers are having, even if they have the same system, they are not using the same software version. So, as I said, we are asking the centers to scan with a protocol, a fixed protocol. And this is actually a harmonized protocol together with the TRACK-TBI. There is a slightly difference with TRACK, means they are acquiring 64 DTI datasets and we are acquiring 32 DTI. But apart from that, we are acquiring the same data, like anatomically it means 3-dimensional T2, T1 flare. In CENTER-TBI, we are acquiring SWI images. For some of them that are not able to, we ask them to acquire the T2 star. And at the end, we are at the end of the protocol, we have a resting state fMRI. Regarding the timing, for the ER, we have the ultra early 2 weeks or 3 weeks and 3 months. And for the admission and the ICU strata, we have the ultra early 2 weeks, 3 weeks. Not in 3 months, and then follow up 6 months, 12 months, and 24 months. Now, what's the issue actually in having all these data? Where do we face the harmonization actually? I like to compare this harmonization with, as a Belgian, with some beer. Do we think that beer is all equal? As a lover, I don't say yes. You can say, okay, beer is just a combination of malt, hops, water, and some brewing process. But luckily, it's not all the same. I leave it to you to define which is the best beer here. But we face the same difficulties actually in the imaging. Are all MRI systems the same? Normally it should appear now, but there is some delay. No, they are not. Are all scan protocols the same? No, they are not, no. So what did we do? We came up with some possible solutions for to harmonize the data. And these 4 solutions I will discuss in more detail. We have a healthy volunteer study, which is led by Professor Pouybasset. I think he just left the room, unfortunately. Oh no, he moved, thank you. We have a phantom study, we have a central reading, and we have a quantitative reporting. About the healthy volunteers, so apart from just scanning the patients, we also asked the centers to scan 9 healthy volunteers, as David mentioned. These is including 2 males, 1 female in the age range of 80 to 35, 35 to 50, and above 50. Luckily, at this time point, most of the centers have finished the healthy volunteer recruitment. Only a few of the centers are just not yet finished, so we are happy about that. Then we have the phantom study. Actually, we asked the centers also to scan 2 phantoms. I will discuss only one type of phantom in this presentation. So we have an isotropic phantom and an anisotropic phantom. I will discuss a little bit the study about the anisotropic phantom, which you see in the right top corner, which is a spindle and a thread is wounded around. And the blue area is actually a region of anisotropic diffusion. This study is actually based on 68 scans from 30 centers, as I said before, done with 3 different vendors, 7 different scanner times, which means that they also have different versions, and with 6 different head coils. And the variability of the FA values, intra and intersites are here below. So we wanted to come up with a solution for this big variability. And actually, with these 68 scans, we tried to build a model, a linear mixed model, that we then could use to actually calibrate or normalize the measurements that we do in these different sites. So based on scan features, let's say, as we see over here, like head coil or scan parameters, SNR, bandwidth, or the measurement itself, we try to use a statistical model that we can use to calibrate all the measurements done in these different centers. That means that if you come up with a new measurement, we can then calibrate actually to a new measurement and calibrated measurement based on this statistical model. Some preliminary results will be shown in the next slide. And you see, actually, maybe it's not very easy to see, but you see a filled dot and an open dot. The filled one is actually the measurement itself, and the open is actually the calibrated. And the different colors are actually the different vendors. And you see that we were able already to calibrate it within vendors, but it remains very hard to calibrate between the vendors. But these show that actually using a statistical model is able to calibrate or to normalize the data already. Then we have a next step of harmonization. That's actually the central reading, which is Icometric's responsibility as well. On top, you see actually some of the features that are introducing actually variability in the reading of the imaging data. And the solutions are below that can be used for harmonizing or let's say harmonizing the reading. There is the common data elements that is used for central reading. These are also used in the CENTER-TBI study. Then the central reading itself, and there is also a quantification analysis that can be used for harmonization. On top, again, the comparison between central reading and local reading, and Thijs van de Vivre, who is responsible for the central reading, has done already a study, a comparison study between the central reading and the local reading. And you see the kappa of CT positive was 0.8 in between site and central reading, and 0.94 between in the central reading itself. But there was less agreement, of course, between if we look to the lesion types itself. The conclusion from this study was already that the central reading is reliable and is more consistent. And to end this presentation, oh, okay, there is 2 slides, there was a delay. Yeah, I wanted to mention again that Thijs has done already a reading of more than 3,400 reports, and this has actually resulted in a very big manual, and it started as a manual, but now it's already a very thick book that can be used for volunteers that are willing to help Thijs for this central reading. We think of publishing this, and it's also part of his PhD. And to end up this presentation, I wanted to, yeah. It ended by itself, exactly. I just wanted to point out that quantitative reports are also a part of actually the harmonization of imaging. So, thank you.